Hello everyone, welcome to John Matt Classroom. So kindly refers to the question. Here we have the function fx is equals to x over square root of x squared minus 1. Number 1, state the domain for the function fx. So notice that here we have the linear graph where we have the domain or real number. Next, kindly refers to the denominator. So here we have x squared minus 1. Suppose we have the function square root. So the domain would be greater and equals to 0. Since the square root is at the denominator, so what we can say is the situation will be greater than 0. So kindly factorize the situation. So x minus 1, x plus 1 greater than 0. So notice that we have the inequalities and this is what we have the positive sign. Next, kindly split the situation. X greater than 1, x greater than negative 1. So illustrate the situation in the real number line. We have a negative 1 and 1. So empty circle towards the right. Empty circle towards the right. So here we have the negative. Next we have positive, negative and positive. So by referring to the sign, we're going to select the positive. So the domain for the function f would be negative infinity until negative 1, where negative 1 is not included. Then from the situation 1 until positive infinity, where the 1 is not included. Next, kindly refer to the second one. Find the vertical asymptote. So kindly refers to the domain. So here we have limits when x approaching negative 1 from the left. So we have the function x over square root of x squared minus 1. So here we have a number line where we have negative 1 and 1. So kindly assume that on the left we have negative 1.0001. So for this part does not exist. Kindly refers to the domain. Same goes to this part does not exist as well. Then on the right hand side we have 1.0001, just the assumption. So if we substitute this part into x, so we will have the negative sign. Then if we substitute this part into the x squared minus 1, very obvious, we will have the situation which is the positive. So for this case, next, limits when x approaching negative 1 from the right for the function x over square root of x squared minus 1. So kindly refers to this part. As we can see, based on the domain, for this part, the situation is does not exist. So we can say undefined. Next, moving on with the 1. Limit when x approaching 1 from the left for the function x over square root of x squared minus 1. So if it refers to this part we can say undefined as well, because based on the domain, this part does not exist. Finally, limit when x approaching 1 from the right for the function x over square root of x squared minus 1. So meaning that what we have to do is to substitute this number as an example into this part and we will have a positive over. If I substitute for this part, same as well, we will have a positive. So finally, we can say we will have a positive infinity. So that is the situation. So kindly take note, here we have some correction. So kindly refers to this part, we have some correction. We have negative over positive and very obvious, we will have a negative infinity. So that is a correction for this part. So as a conclusion, the vertical asymptote would be x is equals to negative 1 and x is equals to 1. So that is the situation for the second part. Next, moving on with the third part. Find the limit when x approaching positive infinity for the function fx and also the negative infinity. So limits when x approaching negative infinity for the function x over square root of x squared minus 1. So based on the situation, if we substitute the situation and we will have indeterminate form, which is the infinity over infinity. So the suggestion would be divide the highest power of the denominator. So in here, what we have to do is to factor the situation. So limit when x approaching negative infinity over square root of x squared, where we can have 1 minus 1 over x squared. So kindly detail the situation. So meaning that in here we have the square root. If I factor the x squared, so we will have 1 minus 1 over x squared. Then after that, we split the situation like what we have in this part. So finally, based on the situation, as we can see, the modulus of x, which is equals to x and negative x, with the domain x greater equals to 0, x less than 0. So here we have the definition. So for this case, we have negative infinity, so very obvious, x less than 0. So meaning that the definition for this part would be the negative x. So rewrite the situation. Limit when x approaching negative infinity, we have x over negative x multiplied with the square root 1 minus 1 over x squared. So if we simplify the situation, limit when x approaching negative infinity, so we will have negative 1 over square root of 1 minus 1 over x squared. So if we substitute the situation into this part, we will obtain 0. And finally, the value of the situation will be negative 1, as the limit when x approaching negative infinity for the function x over square root of x squared minus 1. So that is a situation for the limit approaching negative infinity. Next, move on with the second situation, limit when x approaching positive infinity for the function x over square root of x squared minus 1. So actually we are repeating the same thing, just that for this case it is a negative infinity, and for this case it is a positive infinity. So if it is a negative infinity, the situation for this part will be the negative x. For these kind of cases, when x approaching positive infinity, so x over, we will have x, because in this case we are approaching positive infinity. So here will be the situation for the right hand side. Then finally we simplify and we will have 1 over square root of 1 minus 1 over x squared. Then finally we will have the value approaching 1. So finally the horizontal asymptote for this case would be y is equals to negative 1 and y is equals to 1. So that is the situation for these questions. Next, we have the second part. So if we substitute, we will obtain 0 over 0, which is the indeterminate form. Next, my suggestion would be multiply by the conjugate. So limit when x approaching 8, x minus 8 over, we have the square root of 6 minus square root of x minus 2. Multiply by the conjugate, square root of 6 plus with the square root of x minus 2. So kindly take note, only expand one part. So my suggestion in here would be the denominator. So if we expand, we will have limit when x approaching 8, x minus 8 multiply with the square root of 6 plus square root of x minus 2. Kindly refers to the denominator. Since this is conjugate to each other, so kindly make use of the a squared minus b squared. So in here we will have 6 minus bracket x minus 2. Next, limits when x approaching 8. So here in the situation, we have x minus 8 multiply with the square root of 6 plus with the square root of x minus 2 over, we will have negative x plus with the 8. Kindly factorize the situation. So limit when x approaching 8, we will have x minus 8 multiply with the square root of 6 plus with the square root of x minus 2 over, we will have negative bracket x minus 8. So notice that we have a common terms, so we can simplify. So kindly rewrite the situation. So limits when x approaching 8, negative multiply with the square root of 6 plus with the square root of x minus 2. So finally, if we substitute the value, and we notice that here we will have the third 6. So the answer will be approaching negative 2 square root of 6. So that is a situation for these questions. Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share and subscribe.